Hello friends, and welcome to my channel. And today we're going to look at this training question from Codility, whatever. So a non-empty array A consisting of n integers is given. A pair of integers p and q. P and q are integers within the range from 0 to n minus 1. Then we call this a slice of array A, and also the average of the slice is the sum of all the elements in the slice divided by the length of the slice. And here is a formula for that, for calculating the average. So the question is asking to write a function to find the starting position of a slice whose average is minimal. Here's another condition. If there's more than one slice with a minimal average, you should return the smallest starting position of such a slice. Okay. So this is still a pre-sum problem. So let's first solve it with a brute force problem algorithm solution. So what I'm going to do is to first create a variable which we're going to return as our result, and then we have to calculate for prefix sum. So let's define it as prefix sum. We initialize it a.length. Sum equals to 0, and let's use a for loop to do that. I plus plus. So we're going to calculate sum by adding elements of A to it, and then we assign sum to the prefix sum, and we will also need a global average because we're going to make comparisons and get the smallest average. So average is going to be double. Call it global average, and we're gonna assign it to the largest possible double value because we want to calculate for the smallest value. So now we're gonna calculate for the average with the prefix sum. So I equal to 0, I less than a.length, and I plus plus, and then j equals to j is supposed to be greater than I, right? So the problem states here p is less than q, so j is supposed to be greater than I, so we define it as I plus 1, same range. And then we're going to calculate for the start sum and the end sum, so that we can calculate total. So start sum, and here we have to watch if I equal to 0 or not. If I equal to 0, the starting sum should be 0, otherwise it should be prefix sum I minus 1 position before the position of the prefix sum, and then end sum equals to, it would just be pre-sum of j. Okay, so the total would be add sum minus star sum, and the average, let's call it local average, local AVG, would be the total divided by, here's formula, formula is Q minus P plus 1. Correspondingly, we have J minus I plus 1. Okay. And also, if we just do this, this is going to give us integer division. So to avoid integer division, we have to multiply total or any of the whether it's denominator or numerator. We just multiply with a decimal value. Going to multiply with 1.0. And then we're going to compare the global average and local average. So if local average is smaller than global average, then we're going to update the global average with the local average because we found a smaller average. And we also want to record I by using result. And let's run the code. So the time complexity, unfortunately, is not very pretty because we have this nested for loop, and so the time complexity, this part alone, is going to be big O of n squared. Big O of n squared. So if we submit this, this probably won't pass all the test cases because the time complexity is big O of n squared, and so it would not pass the performance test. But we can just try anyway. The time complexity for this brute force solution is big O of n squared. Let's try this first, and then we'll talk about a solution which is the solution that can pass all the tests, but may not be very intuitive, and it's actually very hard to think about doing a interviewing process. Taking a long time because the time complexity is pretty long, not very good. Come on. Okay. So it's the total score is 60%. We've got 100% on the correctness, but only 20% on the performance. And the time complexity, as we talked about, is big O of n squared. So we need to somehow reduce its time complexity. So before we go to the coding, let's first talk about how we solve this problem. Okay. So so I'm going to restart the problem. Okay. So the problem is asking calculate for the minimum, or calculating for the index of, or first index of the slice with the minimum average. Okay. So we can think of the length of A. So let's assume. Okay, let's assume the slice with minimum average. Okay, or the first slice with minimum average has length n. Let me make this a little bit bigger. Yeah. So there can be two possibilities, right? So case one is if n is odd number, okay, and case two is if n is even number, okay. But in any cases, okay, in either case, n can be divided into smaller slices, right? So that slice can be divided into smaller size. So the slice can be divided into let's say sub slices of 2 or 3, right? 2 or 3. It has to be a bunch of 2, and then because n is an odd number, so there must be also a 3 there, right? So it should be either 2 or 3. It could be divided into sub slices of either 2 or 3. It cannot be divided into 1 because the question is saying that P is less than Q. Okay. So let's say that if that slice it has minimum average, right? So which means that all the sub slices are having exactly the same minimum average. Okay. So so all the sub slices should have the same average as the mean slice. So if you think about that, this must be true because if some of them are having bigger average, then the others must have smaller averages, right? So that would contradict to the statement here or condition here that this slide has the minimum average, right? So I'm just going to write down, if not, then some of sub-slice have larger average than others must have smaller averages. Okay, so that which will contradict the fact that the slice, okay, let's call it slice A, okay, the slice A has the minimum average. Okay, so which means that we can just check only the sub slices with 2 or 3, right? So because if a slice with minimum average and has length n, then it must be we must be able to divide it into sub-slices of 2 and 3, and all the sub-slices must have exactly the same average, otherwise it would contradict the fact that A has the minimum average. Okay? So the same thing goes for the even number. The same goes for this case. So the problem now is reduced to checking all of the slices with 2 or 3 elements and find which one had the smallest average, right? So the problem is reduced to only check the slices of length 2 or 3. Okay, so that will reduce the search space drastically, right? Okay, so if we understood this, we can go back and write the solution for that. So what I'm going to do here is I'm going to first create a mean index variable, and this is going to be the result. So we're going to return that mean index, and we're going to check first for the slices with length 2. Okay, so very simple. So I'm just going to write a for loop. I is less than a length minus 1, because we're calculating, we're going to look at slices with length 2. I'm going to calculate the average. So just going to call it AVG. So that would be looking at the slice of 2 elements. So that would be A of I plus A of I plus 1, and divided by 2.0. Okay, we have to divide by 2.0 to make sure this is not an integer division. After that, we do comparison. And here we also have to define a global average. Okay, so I'm going to call it mean average. Okay, double max value. So if the local average is greater than the or smaller than the global average, then we want to update the index, also the global average should be equal to I. So that this is the checking for length of 2, and I'm going to check for length of 3. So again, I'm going to use the for loop. I'm going to just copy this for loop up and paste down below. I'm going to change this a little bit. So this is going to be -2 because now we're going to add 3 elements. So that will be a of I plus 2 and divided by 3.0. And here we want to look at the average. Okay, but here we have to be a little bit careful because we've seen we've already have a result when we checked for slice of length 2. Okay, for the slice of length 3, we have to consider the result coming from here. Okay, so we have to first look at if average is less than or equals to mean. Okay. So here, if average is less than mean average, then basically we do the same thing. Okay. Well, we update the global average and we update the minimum index. Now, otherwise, else, so that would be if the local average is equal to the global average. In this case, we want to find out which if we got a smaller index. Okay, so here we want to update the index. The index equal to use the math mean index and I, whichever is smaller. Okay. So yeah, so let's run the code. So the time complexity for the loop checking, so we have 2 loops. So the first loop is checking for all the slices with length 2. So the time complexity for this one is big O of n. Similarly here, this for loop is checking for all of the slice with length 3, but it is just one single for loop, so the time complexity is the same. So the overall time complexity of this solution is big O of n linear, which is a lot better than the brute force solution, which was big O of n squared. So let's submit the task. %, right? So anyway, the solution is kind of difficult to come out if that was a real interviewing process. I don't think many people would be able to come up with the solution like that, and so I don't know if it's a practical thing to have, you know, a programming task or problem like that coming in a coding interview, because it doesn't seem to be a very practical thing for people under pressure, and also under certain time, you have to solve it in like 30 minutes to come up with a solution like that. But anyway, this is the solution for solving this problem and get total score 100%. Well, that's it. Thanks for watching, and go have a nice day. Bye bye.